finished. So we're going to look at absolute value equations. So in order to solve absolute value equations, you first of all have to isolate the absolute value. So in this case, we want to isolate the 3x minus 2. So we want to get it on one side by itself. In order to do that, we need to get rid of that 3. We can subtract 3 from both sides. And that will give us this equation here. Now that we have our absolute value bars isolated, we're going to split the constant that's by itself. So here's my constant that's by itself. I'm going to separate that into 12 and negative 12, because whatever's inside these absolute value bars right here could be the equivalent of positive 12 or negative 12. But when you take the absolute value of it, it turns into that positive 12. So we're going to have two equations here. 3x minus 2 equals 12, and 3x minus 2 equals negative 12. And then we're just going to solve both of those. So these are just multi-step equations. You should have learned all about these in Algebra 1. So we're going to add 2 to both sides. It's going to give us 3x equals 14. Beside it, divide it, we're going to divide both sides by 3 here and get x equals 14 over 3. If it is an improper fraction, that's okay. You could write it as a mixed number if you wanted. 4 2/3 would be fine as well. Then we're going to solve the second equation over here on the right-hand side. Process is very similar. Add 2 to both sides. Now we have 3x equals negative 10. Again, we're going to divide by 3. And x equals negative 10/3. And again, I would just leave that as an improper fraction. And those are your two final answers. So for every absolute value equation that you solve, you're going to have two answers unless you happen to end up with the same answer twice, which I've only ever seen happen once. So it won't happen very often. So there's one example. So that one we started out by subtracting the 3 off the end. The next one here, we have our absolute value bars and they're stuck in the numerator of a fraction. So for this one, if we wanted to isolate those absolute value bars, we're going to have to start off by getting rid of that denominator of 8, which means we're going to multiply both sides by 8. So that's going to cancel on the left side here, leaving us with the absolute value of 7x plus 4 equals 24. Now that my absolute value bars are isolated, I'm going to go ahead and separate into my two problems. So the 24 is what gets separated. It's going to be positive 24 and negative 24 over here. And then the 7x plus 4 gets brought down. And now we have, again, our two equations that we can solve. So looking at this here, we're going to subtract 4 from both sides. It's going to give us 7x equals 20. We're going to divide both sides by 7. And x equals 20 over 7. Again, we're going to leave it as an improper fraction. Process for the second equation is very similar. Subtract 4 from both sides. 7x equals negative 28. Divide both sides by 7. And x equals negative 4. So there's my two answers. right, so example 3. Again, for our absolute value problems, we want to, first of all, isolate the absolute value bars. So here are my absolute value bars. Everything else needs to be moved. So this one has 2 different pieces on the left-hand side with the absolute value bars. So we've got to move both of those. We're going to use our order of operations to move things. So in this case, we've got to think about what is happening to those absolute value bars first, and then what's happening second. So first, those absolute value bars are getting multiplied by -2, and then getting added with 3. So we need to move the 3 first. So we're going to start off by subtracting 3 from both sides. So that's step number 1. We got to get rid of that 3. Step number 2, we want to get rid of the -2. And a lot of students see that -2 and they want to add 2, but that's actually not what's happening. So that -2 is being multiplied by the absolute value bars. So there's a little multiplication symbol in there that's not written, it's just understood. So to get rid of that -2, we're actually going to divide both sides by -2. So that's going to cancel those, leaving us with 4x plus 6 on the left equals +9. Anytime you end up with your absolute value bars by themselves, like they are on the left-hand side now, the number on the right-hand side should always be positive. Not until we split it do we get a negative number over there. So now is where we're going to split. We're going to have a +9 and a -9. Oops. And then the 4x plus 6 just gets brought down. And now we have 2 equations to solve. So looking at these 2 equations, we are going to start off with subtracting 6 from both sides. 4x equals 3. We're going to divide both sides by 4 to get x equals 3/4. For the second one, again, we're going to subtract 6 to start off with. That's going to give us 4x equals -15. Divide by 4, and x equals -15/4. I want you to take a minute and try example 4. All right, we're gonna go over question number 4 here. First thing, again, we're always wanting to isolate our absolute value bars. So we want to isolate this here. In order to isolate those absolute value bars, we've got 2 steps we need to take. First step we want to take is going to be to get rid of the 6. So we're going to add 6 to both sides. So that's going to give us 5 times the absolute value of 1 minus 2x equals 25. And now that we have this, we want to eliminate the 5 that's sitting out front. So in order to eliminate the 5 that's out front, we want to divide the left and the right side by 5. So on the left-hand side, the 5s are going to cancel. And we're going to have the absolute value of 1 minus 2x equals positive 5. Now we're going to separate this into our 2 pieces. Remember, we're going to have one with a positive 5 and one with a negative 5. Just like that. I've had some students in the past who write the negative 5 on the left, the positive 5 on the right, and that's perfectly fine as long as you have one of each. And then we're going to solve both of these. So in order to solve both of these, we're going to subtract 1 from both sides. So we're going to have negative 2x equals 4 divided by negative 2. And x equals negative 2. For the second one, again, we're going to subtract 1 from both sides. Negative 2x equals negative 6. We're going to divide both sides by negative 2 and get a solution of x equals positive 3. So hopefully you got that one correct. A lot of times you won't end up with exact numbers like this. There'll be fractions or decimals. One last example here for today. So this one I put on here just because students tend to get tripped up on this one. The reason students get tripped up on this one is because of this negative out front. Oops. So this negative is what tends to confuse people. We're going to start off just like we do every other problem. So we're going to try to isolate the absolute value bars. First thing we've got to do is move the 5. So we're going to start this problem by subtracting 5. So that's going to give us negative 21 on the right-hand side. And now in order to eliminate this negative, we're going to think of that negative as being a negative 1 that's being multiplied by my absolute value bars. So in order to get rid of that negative 1, I'm going to divide by negative 1. So that's going to give me the absolute value of 1 minus 2x equals positive 21. Then we're going to do our split. We're going to split this into positive 21 and negative 21. So 1 minus 2x equals 21 and 1 minus 2x equals negative 21. We're going to finish these up by solving for x. So we're going to subtract 1 from both sides. Negative 2x equals 20. We're going to divide both sides by negative 2 to get x equals negative 10. There's one solution. For the second one, again, we're going to start off by subtracting 1 from both sides. We're going to have negative 2x equals negative 22. We're going to divide both sides by negative 2 to get x equals positive 11.